is my Physics 2212 lab on circuits. So this lab was designed to help the understanding of predicting the behavior of circuits containing resistors in series and parallel, using multimeters to measure the actual values of conventional current and potential differences in the circuits, and examining the behavior of ohmic resistors and capacitors. The fundamentals of physics at play here are these two equations. The first one is current equals the potential difference over the resistance, or voltage over the resistance, and the resistance in ohms is for series current, it is all of the resistors added up, whereas for parallel resistors it is 1 over the resistor plus 1 over the second resistor, etc. And then this other equation relates time to resistance, capacitance of a capacitor, and the potential difference, where the natural log of the potential difference over the potential difference at the start of the time is equal to negative time over the resistance times the capacitance of the capacitor. So my experimental setup for the first part is I set up two resistors, one 40 ohm, 47 ohm, and one 100 ohm. And as we can see, we put the amps before and after the resistors, and it's the same because current is the same no matter what the voltage is. And then when we tested for volts, we got a potential difference of 3 volts in our circuit when unconnected. And so we also tested for volts at various points throughout, and here we can see the potential difference through each of the different sections that we tested. So between points A and B are the batteries, between points C and D is the first 47 ohms resistor, and between points E and F is where the second 100 ohm resistor was. And so we were able to calculate the amps based on the voltage in the resistors, and it equaled what our amps said. And when the amp meter was put in the reverse way, the reading was still 0.02 amps. That's because we're dealing with an ideal scenario. And the volt reading at both interjections was at 3.0 volts. And so here's some more results. The ammeter readings do not change as the voltmeter moved around due to the voltmeter being connected to the circuit in parallel and having a high resistance. This means that the voltmeter adds the circuit, that the resistance added by the voltmeter to the circuit is about 0, and thus does not change the current or the voltage of the circuit to any measurable means. So here's experimental setup 2, where we set up both a 10 ohm and 20 ohm light bulb to a battery and a capacitor, and on the right hand side it's just to the capacitor that was charged. And so the results from this is, as the capacitor charged, the light bulb dimmed due to the current moving slower, and then connecting the charged capacitor to the light made the light turn on slowly and then dim until the capacitor was completely out of charge. So as we can see here, the 10 ohm light bulb and the 20 ohm light bulb had very similar times for the time it took to charge up the capacitor and then discharge the capacitor using the same light bulb. So here's the last experimental setup, where we were testing out this time constant situation, and we eventually got an RC, resistance times capacitor, of 10 point capacitance of 10.399, which is about equal to if we took the resistance of the 30 ohm light bulb and multiplied it by the capacitance of our capacitor. So for the lab report questions, what if you were doing this lab in real life and used an actual ammeter instead of an ideal simulated ammeter? If we were doing this in real life, the ammeter would add some small amount of resistance and thus would affect the current of the setup, unlike the ideal no resistance ammeter. The real life ammeter would also read a negative if put into the surrogate negative to positive. And then if you're doing the lab in real life with a real battery charge and a real capacitor, and you just connected the battery straight to the capacitor, then if there's no real resistance in the ideal system, the capacitor would charge instantaneously due to the lack of resistance. If we were doing this in a real life system, it would not charge instantaneously, as the batteries have some resistance, but not enough to have a significant difference to the capacitor's charging speed. Thank you.